In this video, we're going to start to talk about direct variation. And direct variation is just a special type of linear function. It is given by an equation that's in the form of y equals kx. That k is a constant. What that means is it could be a 2, it could be a 3, it could be a -2, it could be anything we want it to be. It could be a -1, it could be a 1/2. But it always says y equals some number times x. That's direct variation. K is called the constant of variation. One of the things I want to mention that is that an equation varies directly only if it can be in this form. So there will never be any addition or subtraction. There'll be no addition signs or subtraction signs in a direct variation problem. So we're going to just answer this question. Is each equation a direct variation, yes or no? If so, what's the constant of variation? So what we're going to do is we're going to solve for y. We're going to see if we can get it in that form, y equals k times x. So in this one, I would divide by 2 everywhere to get y by itself. Notice that I have this plus on the end. There is no addition or subtraction signs in this direct variation. So this is not direct variation. Look at the next one. We're going to solve for y on each one of these. Well, on this one, when I solve for y, I'm first going to get rid of the 5x by subtracting 5x. I get 2y equals -5x. I'll divide by 2 on both sides, and I get y is equal to -5/2 x. This is in the form of y equals kx. So this is a yes, it is direct variation. What is the constant of variation? Well, the k is whatever in front of the x. You can't even see that very well, so let me change that a bit. I'll highlight it in yellow. So the k happens to be -5/2. In this example right here, can we get it in the form y equals kx? We'll see. We're first going to have to get y by itself, so we'd subtract 4x from both sides. When we do that, we get 3y equals -4x plus 8. Then we would divide by 3 everywhere. I can already tell that this is not going to eliminate that plus, but I'll go ahead and finish solving it. So this is no, it is not direct variation. I cannot make it say y equals kx. There has this plus on the end that makes it not have direct variation. The last one, we're going to go ahead and solve for y, so we'd add 7.5x to both sides. So we end up getting y equals 7.5x. This is yes to direct variation. We can actually see that it fits that form y equals k times x. So my k is actually equal to 7.5. Instead of an equation, sometimes we are just given a table. And so we're going to be able to tell if it's a direct variation if all of our ratios, that's what I'm doing here, is making fractions, ratios, if all of our fractions are equal to each other. And if they're all equal to each other, I will know that that's my direct variation. So in this example, if you look, what I've done is, remember, it's y over x. So I've written 8 over 2, y over x, 12 over 3, y over x, and 20 over 5, y over x. Each of these fractions divide to give me 4. So yes, I can say that it varies directly and that my k is equal to 4. We'll do some examples on the next video.